During this video, we're going to look at the limit in sum of a geometric series. Let's say that we had Tn is a GP, its first term A and ratio R. So therefore we have Tn equals AR n minus 1, and the sum of n is equal to A brackets 1 minus R to the n all over 1 minus R. And if we say that the ratio R lies between the interval -1 and 1, then as n approaches infinity, the successive powers, so R1, R2, R3, R4, so on, they get smaller and smaller. So for example there, if we said that R is equal to 0.5, so R1 is going to be 0.5, R2, or R squared, sorry, 0.25, R cubed, 0.125, R to the power of 4, 0.0625, and so on. So you can see that as n is approaching infinity, it's actually getting smaller and smaller and smaller. So therefore, R to the power of n is going to approach 0, and 1 minus R to the power of n will approach 1. So therefore, both the nth term, Tn, and the sum of the n terms converge to a limit. So what we were just saying there, the limit as n approaches infinity of AR power of n minus 1, it's going to equal 0. And the limit n approaches infinity of the sum is going to be A1 minus R to the power of n all over 1 minus R is going to simplify down to A minus over, 1 minus R, because we're saying that this is approaching 1 as R to the power of n approaches 0. So now we can use this formula to help us find the limit in sum. So looking at that from a different point of view, if we were to look at a graph of the terms, okay, so here we have the terms with a ratio less than 1 but greater than -1. You can see the terms are going to get very, very close to the x-axis, but they're never going to touch. So they converge to a limit. So looking at a problem now with that, a frog wishes to jump from one leaf to another, a distance of 1 meter. It can only jump 50 centimeters on the first jump, then half the previous distance on each following jump. How many jumps will it take for the frog to reach the second leaf? So its first jump is going to be 50 centimeters, its second jump 25, its third jump is 12.5, its fourth jump is 6.25, and that's going to continue on. So we can see our first term is going to be 50, our ratio, or R, is going to be 1/2, and this is going to be like our second graph we looked at with our terms. They're going to get very, very close to 0, but never actually get there. So we're going to have a limit in sum with that, and the formula that we can use, sum to infinity, is going to be A over 1 minus R. So that's going to be 50 over 1 minus 1/2, which is 50 divided by 0.5, which is going to equal 100, and that represents 100 centimeters. So that's saying the limiting sum of this series is 1 meter. So that's saying it will get very, very close to get into that second leaf, but it will never actually get to 1 meter. In our problem here, we need to find the limiting sum of the geometric series 1 plus a third plus a ninth. So what I would like you to do now is to pause the video and have a go at trying to find the limiting sum for yourself. We need to start with a is equal to 1. Now r, we can go a third divided by 1, which is going to equal 1 over 3. So our limiting sum is equal to a over 1 minus r. So that's going to be 1 over 1 minus a third, which is going to equal 1.5. In our example here, we want to look at, so it's asking us for what values of x does the series 1 plus x minus 2 plus x minus 2 squared, and so on, converge. So we looked earlier in the video and we said that they converge to a limit when r is less than 1 or greater than -1. So what I'm going to do there, our r in this problem is going to be x minus 2. So what I'm going to do is replace r with x minus 2. Now I need to add 2 to all sides, and that will equal 1. So therefore, x is less than 3, but greater than 1. In our problem here, we have a geometric series, 5 plus 10x plus 20x squared plus 40x cubed. It's saying it has a limiting sum of 100, and we need to find the value of x. So some of the information I know already. A is equal to 5. R, so I can go 10x divided by 5, so it's going to be 2x. And we know the limiting sum is equal to 100. So we need to find the value of x. Okay, so the formula for the limiting sum is a over 1 minus r. So substituting all the information I have, I know it's going to equal 100. I know a is 5. Then I have 1 minus 2x. Okay, so I'm going to move that 1 minus 2x to both sides. So I'll multiply both sides by 1 minus 2x. Then it'll give me 100. 1 minus 2x is equal to 5. Expand that out, I get 100 minus 200x is equal to 5. Minus 100 to both sides. Negative 200x is equal to negative 95. And finally, divide by negative 200. And that'll work out to be x is equal to 19 over 40.